magnitude of reaction at hinge A and angular momentum. Now here to find out all these things. So what is the rod? Rod is of mass m. This is hinge is telling A and this is B. Now I'm testing again your basics. Just know what all you learned, how you can apply. It will describe conical pendulum. In doing so, the tip B what happened will describe circular path, and the rod what happened will form a slant face of a cone. The rod what happened will form a slant face of a cone. Take pen or pencil, just swing like this. You can see this. So take this pen or pencil, anything, no? No, don't do like this. Huh? Some brain should be there, please. Huh? Minimum brain should be there. Huh? So there's one end I'm holding. I'm going to, the tip here will describe circular path, horizontal circular path. What happens the rod, this particular pen, it will describe the slant face of a cone. So it will form like a similar to conical pendulum. It's angular momentum, all other things I'm asking. So what is that angle, theta? What are given things? Omega is given, length is given, mass is given. So we should find out that angle theta. First we'll do one thing. First we'll get the angle theta. How to get that angle theta? So let me assume a, so here what are the forces that will be acting? The weight mg. There's a weight mg. Then I'm going to assume a small element. Let this element be at a distance r. This is theta. Pseudo force dm omega square r sin theta, or call x dm omega square x. And what is sin theta? Sin theta equal to x by r. X equal to r sin theta. Now tell me, like for equilibrium, so this is like a centrifugal force, no? You can put centrifugal force. So let me go for the torque about point A, the net torque about point A. Torque we will set up, torque due to weight should be balanced by torque due to centrifugal force about point A. For equilibrium, net torque about point A should be 0. Torque we will set up torque due to weight. Torque due to weight, how much it should be? Mg L by 2 sin theta. This should be equal to torque due to centrifugal force. Integral of dm omega square x cos theta. Now from where you brought this, sir? From where it has come? What is dm? Dm omega square x will act like this. So what is this distance? X cos theta. Force into perpendicular distance. Then what is x? X you can write r sin theta. So I think this should be r cos theta. This distance will be r cos theta, that will be x sin theta. Let me put all the things. What should be the length? 0 to L. So mg L by 2 sin theta. Dm, what you can write? Mass per unit length, lambda into dr. Omega square. X you can write it as r sin theta. This is r cos theta. Sin theta, cos theta, one sin theta will get cancelled out. So m g L by 2, one sin theta will get eliminated. So cos theta will come outside. Or time being, let me write it there only. Lambda omega square cos theta. This everything will be r square dr, 0 to L. mg L by 2. Lambda is what? M by L omega square cos theta. This will be L cube by 3. Theta is what being asked, no? So M get cancels. One L also get cancels here. So finally, what is cos theta? Cos theta should be equal to 3g by 2L omega square. I'm writing that in corner. Check it once. This angle made by the rod with vertical when it is swinging. So there's a find the angle theta, we got it. Then magnitude of reaction. Why that reaction should come? Why that reaction word he has brought? Yes, there'll be reaction. No? So what centrifugal force will try to do? Will try to push the rod towards right. So there'll be reaction force. So call this is Rx. Hi, it is rotating. No, on its own cannot rotate. Somebody should rotate. So there'll be reaction in the inch. No, Rx should be equal to Ry is equal to mg. Second part. What are Rx and Ry? Reaction at inch. Ry minus mg should be 0. So therefore, what is Ry? Equal to mg. How to calculate Rx? Rx is the total horizontal centrifugal force that is acting on the rod. The net horizontal force that is acting on the rod. So how to calculate Rx? Rx should be equal to integral of dm omega square x sine theta, component of that, dm omega square r sine theta. Or okay, this will be further dm omega square. What is x? X is r sine theta. Further, what is dm? Lambda into dr. So lambda omega square sine theta r square r dr 0 to L. So what is Rx is equal to lambda omega square sine theta L square by 2. Lambda is m by L. So m omega square L by 2 sine theta. This will be the reaction. The total reaction will be vector sum of these two. Say centrifugal force will try to drive it away. So the hinge weapon will resultant force it will exert in this direction. And now after this, the angular momentum is needed. Now how to get that angular momentum? Anybody? How to get angular momentum?
I omega.
Don't say answer, no, workout, no. You can't just see and write it. Already I told you. Looking at that, never tell like that. Why that angular momentum? Will it be a constant? L bar will be constant, or magnitude will be constant. Angle will be changing. Angle will be changing. Just now conical pendulum, how we did, similarly we should do for this particular, but different points of the rod, they are at different distance from the axis. I strictly put this axis. The tip of the NB will move in circular path. That's why you can see some sort of like a cone. That's why it is called like a similar to like a conical pendulum. Now you know that I want the expression for L bar. So for this, again I'll get into the diagram. Let me start with again the basic diagram. Let me construct the diagram. Please, most of you have to put effort. because I think you never get questions in advance where by seeing you will get it. By seeing you'll never get any question where by seeing you can answer.